Hey everyone, my name's Harry Tormey. I'm the CTO of StepChange.work. We're a consultancy that helps you make your apps and databases faster. Today I'm going to be talking to Ananth. I actually worked at Coinbase with Ananth. We didn't overlap on a lot of projects, but we would talk all the time about database performances and applications and infrastructure and fun stuff like that. Ananth isn't going to be talking about Coinbase stuff today, though. He's going to be talking about his time at Nextdoor and specifically how they solved a Postgres scalability issue with Nextdoor's Django application. So, Ananth, over to you. Why don't you give an introduction and tell us a little bit about you?
Thank you, Harry. Thank you for having me on your videocast show. But thank you. My name is Ananth. I'm currently at Rippling, just recently joined. And prior to that, I was at Coinbase with Harry. And before that, I was at Nextdoor for many years. So, without much further ado, let me talk to you about the problem we faced at Nextdoor. So, just to give a little context, Nextdoor is an app, it's a social network which is local. And so, what that means is the network that you have is geospatial. You belong to a network because you belong to a neighborhood, and you belong to a neighborhood because you live there, right? And so, with that product requirement, engineering needs to handle a lot of geospatial data. We need to know where our users live, where is their geolocation, so we can put them in the right neighborhood. And Nextdoor also allows people to create their own neighborhood. So there's a lot of geospatial data involved, is the point. And when Nextdoor started out 2011, it was a monolith Django app with Postgres as the database. Postgres chosen because of its excellent PostGIS geospatial extension. And at one point, we started having performance issues for many reasons. One of them was around the geospatial queries. So, for example, if a user comes in, draws their neighborhood, and creates a neighborhood, there are a bunch of geospatial queries that go out. Many of them were not very performant. And sometimes we used to have outages. And it made no sense that users are not able to see their posts on their neighborhood because somebody else couldn't create a neighborhood. So it felt obvious at that point that we need to move all that geospatial data out to another database, create a service around it. So that was
Can I
one
just,
reason.
can
Yeah.
I just can I just pause to take a step back? So, some people who are watching this, both me and Ananth are based in America on the West Coast, may not have access to Nextdoor. So just to kind of give you a visual for what this is like. So I believe with Nextdoor, at least when I had to sign up, you had to prove where you lived.
Yes.
And that could either be done via the credit card that you signed up with, where they charged you a nominal fee, which I
Yeah.
think they gave you back, or, you actually got a postcard, right?
Yes.
And
Yes.
so it would then show you something that was kind of comparable to Facebook, like a feed of stuff that was going on in your neighborhood that was posted by your neighbors. And some of this stuff would be things for sale, some of it would be like local neighborhood news, some of this would
That's
be like neighbors complaining about people or being really petty as neighbors can be. But it was a pretty cool product. And so again, Nextdoor is a Django application that, Django famously has an ORM that abstracts away a lot of the inner workings of the database. So I just thought I'd like get that clear.
absolutely right.
And
Yeah.
yeah, so continue on with your story, Ananth.
Yeah.
Excited to hear more about these
Yeah. Thank you.
problems.
Thank you, Harry.
Yeah.
Yes. I wasn't aware the wide user folks are going to watch your show. But yes, and once again, to drill down, you become part of a social network that is defined by geospatial boundaries. So you don't become a
Hmm.
network because they're your friends, you're part of the same college, but it's because you live in that area, right? And so as I said, one of the performance issues was poorly running geospatial queries. The other was when you use a Django ORM, there is this impedance mismatch between the ORM, which is an object, and you have tables in the database. And if you just go user profile dot residence dot address in a Django ORM, it feels obvious. But at the back, you're running joining big tables and running queries, and those were also not great. And uh, there could be a better way for everyone to code so that we don't make these assumptions. So the Django ORM was another issue. The third part was that the amount of data at the point that we decided to take on this project, half the data in the Nextdoor database was geospatial. The reason why geospatial data is so much, and I should mention this more detail, is that we were not just using point data, we were using polygons. So your house was represented by a polygon. Plus, neighborhoods were large polygons that collected all these points together. So those were larger objects and they took up space, right? So
And
this, yeah,
how do you do indexing with that, Ananth?
PostGIS, the extension supports geospatial indexes. Hence, we use that's super powerful. Without that, you really couldn't function. So that was very important.
Hmm.
So it was all indexing provided by PostGIS. And then the other, where was I? The size of
Polygons,
the
yeah.
data. Yeah. And the other problem is that geospatial data, address data keeps changing. So in an ideal world, we would like to keep updating the data, because if you update the data, many people who can't find their address or can't find their neighborhood, can be served better. But we were not able to do any updates because that would hit production database with a whole bunch of writes. So we needed another solution where you had another database which was where the schema was done in a way that you could allow updates to happen easily. So I'll come to that when we come. So those were the reasons you needed a geospatial service which would take away the load from the Nextdoor database. And I might be going a little ahead of time, but once we actually did the migration, we found out that about a quarter of the load was being geospatial. So 75% of the queries went to, not the queries, the load on the database was about 4 times on Nextdoor and to 1 on the actual Postgres database. So
So just kind of like to kind of give people a little bit more of a flavor of when you say load, kind
yeah,
of what you mean, right? Because the actual GIS data,
yeah,
that was pretty large. So are you
yeah.
talking about like memory, CPU? Can you dig into the
CPU,
details? Yeah.
yeah, the CPU largely again because the geospatial queries were computation. So there was a lot of CPU hit along with, when you had all these indexes going, you would have to do a few PostGIS computations. So that was the load. Plus, the writes were not as many on the Atlas, on the PostGIS database, but enough because you were creating new neighborhoods. You could potentially be adding in new addresses and stuff like that. And at the end, we were having about 30 million calls to the Gaia service. The API calls about 30 million a day.
And in this, and to make, just to also give an important piece of information, like what year was this? Because I
This was
believe this is
around,
before.
yeah, this was around 2013, 2014. At that point, we were not using RDS. We were hosted on AWS, not using RDS. We were, installing our own Postgres databases on an EC2 instance. So it was pretty manual at that. There was a lot of handholding we did to bring up the instances, bring up replicas, and all that sort of stuff.
Oh, that's awesome. Those are details. Well, continue on with your story, Anant, about like how you dealt with these issues. Like, yeah, tell me a little bit more about that.
Indeed. So we could think of this migration and the creation of this new service and the migration to the service in 2 steps. One, we had to port the existing Django application to use the new APIs, right? So create the new APIs and port the application. The problem there is that a lot of the references to residence data, neighborhood, plot data was all within the Django ORM. So we had to sit down file by file, go through, do searches, find patterns, and replace them with the APIs. So it took a team of 2 or 3 ICs about 3 months to do, right? And
Hmm.
that is a lot. One of the reasons was our unit testing wasn't great. So wherever there was no unit testing, we had to come and write the unit test and make sure we make these changes without any, disruptions in uh, service. This data is actually very important because the user is connected to their neighborhood via the residence ID. So user has a residence ID. That residence is connected to a neighborhood. So if you mess up residence IDs, you return the wrong thing, you place the users in the wrong neighborhood. So
And just
that's the important.
also kind of like to bring it back to the product.
Yeah,
for a second, right? So that's really critical because Nextdoor's concept was that you're sharing news and opinions with your neighborhood. So if you're kind of in one part of San Francisco and then you're getting and seeing all of this stuff in another part of San Francisco, that fundamentally breaks the
breaks the
trust of the
trust.
user. So if you
Yeah,
screw that up, that's pretty
pretty bad. Yeah,
critical.
yeah.
So question for you is like, okay, so what prompted this migration? Was there specific things that you forecast were breaking? Was there incidents? Like, tell me a little bit about that.
Yes, yes. So there were incidents. There were outages caused by poorly running Postgres queries, right? So some of those queries, when you create a new neighborhood, we allowed users to come in and draw a neighborhood. When they drew a polygon, then we would collect the polygons underneath and bring out a new neighborhood. Some of those computations were poorly written, tech kind of thing, and they would sometimes time out, bring the site down, all kinds of stuff could happen. So there were problems, performance problems. Plus, there was a problem of the future. We realized with this much Postgres data sitting in this database, the backups were needlessly large. Right? All kinds of other stuff. If you want to go international, you're going to add more geospatial data, which will again be large. So it kind of made sense that you move it to another database.
That's some really good details there, Anand. Please continue on. I want to hear some more.
Yes. And so when we started the, porting porting it to the new APIs, it was fairly grunt work, but it got done. There was no issue. It took a little bit of time. We got it all done, and we were ready to do the migration. The migration was more complex, and the reason for that was when we set up the new database, we took the opportunity to change the schema. It wasn't like you took the same set of tables from the old database and just moved them over. We changed the schema. And why did we change the schema? One, because there were issues with the old schema. The way a few foreign key references were set up wasn't ideal. But also, we wanted a way for new data to be added to the production database in bulk. So let's say you get an ETL update. Today, if you start writing to the tables that is there, it will just slow down the whole database. You can't write because of the number of indices.
Mhm.
So you want a way of possibly writing it to a brand new table, swapping out tables, stuff like that. We also wanted a way to, say, launch a new country. You add new tables for a new country without bringing down the service for anybody else. Don't go into maintenance mode. And to do that, for example, one of the things we did was we created a public ID table. So there was a table which had a public residence ID mapped to a private residence ID. And all the data was in the private table. So if you wanted, you could just swap that private table out, bring in a new table. Those were the kind of reasonings we had. And so because the schema changed, we had a migration script that picked up all the geospatial data from a replica database of the main currently running database and wrote it to a new instance, which was going to become the new database. We wrote it, we created triggers on the Postgres database that once you write it, there'll be some more delta information coming in. We can pick them up and update it. So I won't go into the details, but there was some setup at the end of which you had a functioning new database, Postgres database. We called it Atlas. So for ease, I'll continue to call it Atlas. So there was a Nextdoor database and there was the Atlas database, which is a new one. We maintained a system of dual writes. So the
Yeah, I
Gaia
was going to
API,
ask that next. Yeah.
yes. So the API would have writes to both the Nextdoor database as well as the new Atlas database. This is really critical because if the migration fails at any point, something doesn't work, you can always roll back. So the whole principle in all of this is you've got these steps, things can go wrong. Always be prepared to roll back even at the last stage. Right? So
Yeah, that's
that
a
was the
good
number one
principle.
thing. Yeah, very important principle. So dual write was critical. Reads were all initially coming in from the old database, right? But we were also reading from the new database and sampling that data to see whether they were the same, right? So there was a lot of, there's a lot of, what's the right word? Uh,
Validation.
Infrastructure work we did,
Yeah.
right? So to make sure that the data was correct, also to make sure that the APIs were performant, right? So we
Hmm.
measured a lot of stuff. And we made this migration go really slow. We first put 1% of traffic, 2%, 5%. It could have gone much faster, but there was a concern that there might be issues if we don't migrate correctly.
And just to, ask another question about the scale, at the time of migration, like how much data were you migrating over? Because I presumed you did a dump or a snapshot at a certain point, loaded it up, and then had basically the dual write system in place.
Yeah.
What was the scale of data for that?
It's about 200 gigabytes is my memory,
Hmm.
on the order of 200 gigabytes.
Oh,
Right.
okay. And
Yeah.
the timeline for this, how long did you have the two systems running in parallel with the kind of phased over 1%, 5%, or whatever traffic? Like, how long did you keep that running before you were
If
cool
my
with kind of,
memory strikes me right, it's about 6 weeks.
oh, 6 weeks.
We had
Okay,
this six
okay.
weeks.
And was there
And
any edge cases or things that were caught by the validation? Like,
yes, yes. So we actually had to respin the database again because there were issues in the writing. Right.
oh, okay.
And so we found the issues, we fixed them, and then restarted the process. We found performance issues in the APIs that we had written, like something taking much longer than the equivalent, and stuff like that, because there was no other way to clearly test the new API. So in a way, it was also testing the new API, right, with traffic. So, and I think
And
that, go ahead.
yeah, go on, continue.
Yes. And so I think we, it was a way to test the correctness of the API, the performance of the API, and I think critically to make sure that we, in the primary migration process, nothing went wrong. So, for example, the whole set of IDs needed to stay stable. So, if a user X was at mapped to residence ID 5000, they should continue to remain mapped to 5000 in the new world. So, all that stuff we just needed to make sure.
And just so people understand, like under the hood, right, you had your ORM and
Yeah.
most of the non-GIS stuff like was the same. But
Yeah.
for the GIS stuff, you had a separate service with a separate set of APIs
Yes.
that were plumbed through to that so that like if the GIS stuff fell over, other parts of the site might still be able to continue. Is that correct or is
Absolutely.
there yeah. And
Absolutely.
so what kind of like, once you landed this change, what kind of performance increases or benefits did you see in the aftermath of it?
Great question. So, I think the outages that we had caused by poorly running Postgres were removed. We didn't see any more. Largely because the reason they were happening in the first place was because of the nature of the ORM, the way those queries were structured, and they were not correct. In the new world, we were writing raw SQL almost. So what we were doing was there was no Django ORM in the new service. We used SQL Alchemy, which is a
Uh-huh.
Python. It's a Pythonic way of constructing SQL queries, and so the quality of our queries were much better than what Django would generate given what you were trying to do. So I think there
Mhm.
was a huge performance boost to that. The other thing was that it actually enabled us to go international. 6 months or 7 months after that, we went international. We went to 7, 8 countries in Europe. And each of those launches, we were able to load data without having a maintenance mode
Oh
because of
wow.
the way I described those private and public tables. And geospatial data shards nicely by geographic regions. So, you had separate tables for Great Britain, for France, for Italy. All of that was possible because you had this new schema.
Oh yeah, and so can you maybe talk to us a little bit about the schema design before and after and like maybe, like how you any kind of backend configuration stuff that would be interesting to our listeners?
Yes. So in the schema, the one thing we did was to keep a table which mapped a public ID. So this public ID is a stable ID which will be used by the rest of the system and cannot change, which was mapped to a bunch of private IDs. So there was a residence public ID and a residence private ID. That residence private ID had a foreign key reference to a residence private table. And you could just drop that table, bring in a new table. You could do stuff like that because, you know, it was not public facing. You're not changing the ID of the public. Right? So that was one thing we could do. The other thing was that we added in triggers. So Postgres has a way of sharding where you can add in triggers and say, if you are adding this row and the country column for that row is Great Britain, then go to this table and write it. And
Hmm.
so we effectively sharded out all the countries, right?
Uh,
And that was made possible because of the way we changed the schema. So all the countries were private tables, right? And the public table remained the common public table for everyone.
and I suppose one other kind of random question about web versus mobile. Was there any particular differences in behavior there between the two different ways that people interacted with this? Was it like,
Great. Yeah, in the app, yes, there were certain features. You couldn't really draw your own neighborhood on the mobile app. It was too
mhm,
hard. There were certain features that were not there. But from a geospatial point of view, uh, not too much difference.
and
There
no
would probably
AP,
be more. Yeah, go ahead.
yeah, no API kind of querying kind of
No, no,
differences? Okay,
no,
okay.
not really. Not
Mhm.
really, not at that time. So,
Well, so I mean, a long time has passed
yes,
since the
yes,
Nextdoor days, and like Postgres continues to be an absolutely awesome beast of a database. There's
yeah,
great managed services options. There's all sorts of new serverless approaches, and AI is a big thing that can help you write like better SQL. There's all
yeah,
sorts of new developments in the Python world, like Fast API. So imagine you were tasked with doing this again today. It's
good. Yeah,
2024. Ananth is
yeah,
doing, I don't know, next door. What
yes.
kind of things would you tell 2024 Ananth to do, and
Yeah.
how would you go about it?
Great, great question. I think the part that we needlessly struggled a lot was in actually porting the application to use the new service, right? I think if you have AI, Gen AI, with all of that, you could have found the patterns, replaced them, built out unit tests much faster than what we did.
Hmm.
So I think there would be a huge win. The tooling is much better today than it was then. So that would be a huge win. The other thing is this was a large infrastructural project, and often the problems you face with that, especially in smaller companies that don't have enough resources to take on these kind of projects, is the way this is sold to the rest of the company, right? Initially, when we started, we said, hey, we'll do this whole thing in 6 weeks, right? And because none of us had ever done something like this before, there needs to be a better sense of how to message. How do you say how much time this will get? What does it buy us? So all those things matter because that makes it socially better to be delivered to the rest of the company, to leadership. So
That's a
those are the
really,
kind of learning
yeah,
lessons
that's a
we.
that's a timeless lesson as well. Like, I
Yeah,
mean, explaining the benefits of, hey, if we don't address this
yeah,
and we try to go international,
yeah,
the site's going
it
to
will.
melt down.
Yeah,
Or, hey, here's a projection of our growth in traffic versus like how well the databases are going to hold up. We need to do this. So those are really, really good insights.
yeah.
Well, Ananth, like it was absolutely amazing talking to you about this, and thank you so much for uh, you know, uh, taking the time to talk about this. If you are hiring at Rippling, and I believe you are, right? And it's
Yes,
it's a bad economy right now in May 2024.
yeah.
How should people reach out to you if they're an absolute kick-ass back-end or front-end developer and they're looking for a new gig?
Great question. I am on LinkedIn. Can I send my LinkedIn connection?
Yeah, I'll drop it in the show notes, and I'll make sure that you're linked on the Step Change blog where we put out like the
That would be wonderful.
interview.
Yes,
Awesome. Well,
that would be
thank you so
wonderful.
much.
Thank you.
Thank you so
Yeah.
much for talking to us, Anand. Goodbye.